Okay, so well done. I hope you've done that one. Now you've used the oscilloscope to measure more accurate values for both the frequency and the peak-to-peak potential difference that's coming out of that signal generator. So now we've got a relatively simple circuit here, just a resistor-capacitor combination. The resistor is labelled as 1 kilo ohm, the capacitor is a tiny capacitor, just 0.1 of a microfarad. So using those two numbers you should be able to calculate what the predicted time constant would be for that circuit. Okay, so now what we're going to do is we're going to separate these two connections. So the signal generator is acting as our power supply. I'm going to ask you to connect the green terminal to terminal B and the yellow terminal to terminal A. So now what we've got is a square wave that is constantly charging and discharging that capacitor in that circuit there. We're now going to use the oscilloscope to measure the potential difference just across the capacitor. So the two connections there, again it's important that the black connection is connected to the bottom of the capacitor, so the black connection is connected to the green terminal there, and the red connection to the top end of the capacitor. So those two connected to labels D and E. And then what you should see on the cathode ray oscilloscope, you should see a signal that's showing the charging and discharging process. Your booklet now asks you to use the instrument again to measure what you think the time constant is of this circuit, using the idea that after one time constant the potential difference will have fallen to 1 over E, or about 37% of the maximum value. Okay, if you can do that now, that'd be great.